Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 57 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and get your gear. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to show you my solution to the homework assignment that I gave you in lesson number 56. But I must first ask, how many of you guys were successful? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, but never fear, I'll show you my solution today. And I'm hoping that you guys are starting to understand this, because a lot of these homework assignments, I'm really not trying to teach you programming. I'm really not trying to teach you circuits. I'm really not trying to teach you embedded systems. I'm trying to teach you math. And I'm trying to show you how elegantly and easily these complicated problems become if we just learn a little math and do a little math. And I'm trying to teach you that math. And I hope you guys enjoy it. I hope that you're enjoying this class. That I'm trying to teach you guys this stuff. Okay, so what was the homework assignment? Let me get out of your way. That was not getting out of your way. Let me get out of your way. There it is. And then let me come over to the circuit that we built last week. And what I showed you last week how to do is I showed you how to connect a joystick to the Raspberry Pi Pico W, and then I showed you how to nominally interact with the joystick. But what happens is we were moving the joystick around, we were getting crazy numbers, like in the center when it was just in the neutral position, we were getting numbers in the some 30-something thousands, and then if I moved it to the left, it was getting things, or if I moved it up, it was getting things into the 60-something thousands, and move it down, it was getting down into the hundreds of something. And so there was just no way that you could interact with this joystick in an intuitive way until we calibrate it to where its performance, its reported numbers more intuitively match what you want. And so what the assignment was, and for all of this lesson, I am leaving the leads coming out to the right, and then I'm holding it like this. And when you go to the left, I wanted to see a reading of minus 100. When you go to the right, positive 100. When you go down, I wanted to have a minus 100. And when you go up, I wanted to have a positive 100 on that axis. So all of a sudden, you kind of have a coordinate axis that begins to make a little sense. And in the center neutral position, you should be reading something like 0, 0. So in order to do that, what we're going to have to do is we're going to have to do a calibration. Okay, we're going to have to do a calibration. And so to start with, we're going to have to make some measurements. And in order to do that, what we're going to need to do is we're going to need to jump in and kind of write a quick program where we're taking the readings off of this joystick. Also, I guess I should show you a couple of other things real quickly. You can see, and I'll turn it this way for this just so that you can read it, that top that top pin is labeled ground. And what I do is I bring the ground to physical pin 38. And then the next pin down is 5 volts. That actually needs to go to 3.3 volts, which is physical pin 36 here. And then I have up next, I have the VRX, and I'm calling, or this is the X value. This is what they call X, like this, but I'm calling this the horizontal and I'm calling this the vertical. Okay, this is vertical motion. This is horizontal motion, but the VRX labeled pin, that is going to go to GPIO pin 27, and then the VRY is going to go to GPIO pin 26. And so hopefully you still have this hooked up from last week. And then remember, this is going to be the orientation that I work in, and this is horizontal motion, and this is vertical motion, okay? And so let's see if we can write a real quick little program to get some measurements off of this thing. And let me come over here to our code view, and let's see if I can go ahead and get this where you can see it a little better. I should have had these windows set up before I started the program, but give me just a second and I will get it. Wow, that is touchy. There it is. Okay. So now we are connected to GPIO pin, so I'm going to have to import machine like that. And then we always need some delays in there, so I'm going to import time. And then we're going to do some calculations, so I'm going to import math. All right. Now I have to create my joystick object. My horizontal joystick reading, I'm going to call hjoy, and that's going to be equal to machine.adc for analog to digital converter. And we said that horizontal was connected to GPIO pin 27. All right. And then I have the vertical joy like that. You know what? I hate doing that. I'm going to say H pin is equal to 27. And then I had V pin is going to be equal to 26. And so as I'm sitting here talking, teaching, in the back of my head, I'm thinking, I really need to be good and give pin names. And so this H-Joy stick is going to be connected to the H pin like that. And then V-Joy is going to be machine.adc. And I don't need this in there. That was a mistake. And then machine.adc for analog digital converter connected to the V pin, the up and down pin like that. Okay. Now we've got those things going, and so that is pretty good. So now what are we going to do? I'm going to create a while loop. I'm going to say while true, true. When is true, true? True is always true. We're creating an infinite loop there. And now I'm going to make my measurements. My H-val is going to be the value when I read from what? H-joy, the H-joystick. And I'm going to read an unsigned U 16-bit number. Now, the 16-bit number is really where you're getting all of those crazy numbers from, because 2 to the 16th is something like 65,536. But if you start at 0, then it becomes 65,535. And then half of that, half of 65 is 32,500 or something like that. And so then you start getting all these crazy numbers. And also when it seems like you go to the extreme values of the joystick positions, you don't seem to go all the way back to 0. So we gotta get this cleaned up. But to do that, we've got to make a few measurements. So we've read the horizontal value. Let's read the V value, the vertical value, and that's going to be equal to vjoy.read underscore unsigned 16 and open close. And now just for good measure, let's print those things out. And so what I'm going to do is I'm going to print, I'm going to make it a little, I'm going to print, and I am going to print the horizontal cal. Why H first? Because right, H was kind of left and right, and that's kind of like what you would think X would be. So the H, I'm going to print the H val like that, and then the V val like that. Those two things that we just did. Now I'm going to do a time dot sleep in milliseconds of about 200. I hope that's right, if I remember that right. Okay, I need everyone to hold their breath. Let's just see if we start getting some numbers. Hold your breath. Giddy up. Okay, so we are getting numbers, and indeed they are crazy numbers. Indeed they are crazy numbers. You see, they are all over the place. Okay, now what is it that I need to do? That when I'm going to do left and right first, and I need to get 2 data points. I need to get the 2 data points of the endpoint. So now watch this. When I move all the way to the left, why did that one not do anything? Okay, when I move all the way to the left, that horizontal value goes to 65,535. So when my first data point then is when I read 65,535, what do I really want that to be? Minus 100, okay? And so I need to write that down. So I'm going to come over here, and what I'm going to say is that when I read 65,535, that should really be minus 100 because that was all the way to the left. So I have one of my data points now. So let's come back over here. And now what do I need? I need the other one. So when I go all the way to the right, I am reading about 250. When I read 250, what I really want that to be is what? 100. So then that is going to become my second point is I'm going to say if I read 250, I really want that to be 100. Now what do I have? I have 2 points. What do I want? An equation of a line through those 2 points. Okay, so I think I'll go ahead and do that before I do the other measurements and so forth. And so this is just exactly like all the other lines that we've ever done in all the classes that I've ever taught. But what's the only difference is here, these are a little bit kind of strange numbers. And so don't get afraid by strange numbers. That's what I used to tell kids when I was teaching math. Like if you say y equal mx plus b and you say y equal 2x minus 4, they're just happy as can be. But if you give them a problem where the answer is y is equal to 3.275 plus 3 million x times x plus 3,245,000, they fall apart and they say, well, that can't be right because it's not small numbers. Well, welcome to the real world where things are not always small numbers. But I digress. Okay, so if I want an equation, through those 2 points, what's the first thing I have to do? I'm sorry, I'm trying to get this in a convenient spot to work on it. Okay, I think this is going to work. Okay, so now what am I going to do? I'm going to want to calculate the slope, m. And what is m equal to? It is equal to y2 minus y1 over x2 minus x1, like that. And this is making a little bit of a clicking noise that is kind of annoying me. Okay, let's see if that works. Okay, now what is my y2? My y2 is over here. So that's 100 minus this one, which is minus 100 over x2, which is 250 minus x1, which is 65,535. Don't panic. Don't panic over these numbers, okay? Take a deep breath. Take a sip of coffee. Don't panic. Math is your friend. Trust the plan. It's going to work. So what do we have? We have m is equal to 100 minus a minus 100, which a minus is a plus, so that would be 100 plus 100. So in the numerator, we have 200. And then in the denominator, we have 250 minus 65,535, which is 65, and then that is 285. Just plug it into a calculator, and then this is, because the larger number is negative, that's going to make this whole thing negative out here. 250 minus 65,535 is actually minus 65,285, and now you can put that in a calculator, and you get the slope is the minus, and then it is 0.00306. Like that, okay? Now we need the equation of the line, and what we know is y minus y1 is equal to m onto x minus x1. All right, now we're going to say y minus y1. What is y1? It is minus 100, so it's y minus 100, and that's equal to m, which is minus 0.00306 times x minus x1. What is x1? Our friend, 65,535. Okay, now what do we need to do? We need to distribute this slope to get rid of the parentheses. And we're going to say y minus a minus is a what? A plus. We're going to say that's y plus 100 is equal to minus 0.00306 times x. And then a minus times a minus becomes a plus, so that's going to be plus 0.00306 times 65,535. Put that in the calculator, and you're going to get it is plus 200.766. Plus 200.766. Now, what do we need to do? I need to get rid of this 100. So what do? I subtract 100 from both sides of the equation, and I get y is equal to minus 0.00306x plus, okay, I'm subtracting 100 from both sides, so that becomes 100.766. So 200.766 minus 100.766 is 200.766 minus 100 is 100.766. Now I just need to use my variable names that I'm going to use in the program. What am I trying to get? A calibrated horizontal. So instead of hval, which I start with, I want to turn it into hcal for the calibrated value. So I'm going to say hcal is equal to minus 0.00306x. Not x. I'm putting it in terms of the real variables, which was what? Hval was what I measured, and I'm turning it into hcal plus 100.766. Guys, does this make sense? All right, this takes an impossible problem and it kind of makes it sort of easy. Okay, hey, I think I'm going to go ahead. Let's go ahead and do the other one. Let's do the math on both of them. Okay, so that time, right, I need to let you see what I'm doing here. I was doing left and right, which is the first number, and right 65,535 over to 250. Now this time we're going to go up and down. And so if I go down, I get about 250, okay? And when it's down, I measure 250, but what do I want? I measure 250, but what do I want? Minus 100, right? Minus 100 when it's all the way down. And so what did I measure? I measured 250, but what do I want that to be? I want that to be minus 100. So that is 1 point. And you can't see that, can you? Minus 250, 100. Okay, now let me go get the other point. All right, let me go get the other point over here. And then what am I going to do? What am I going to do here? I'm going to go up. And when I go up, I'm getting 65,535, 65,535. Well, what do I want that to be? I want that to be positive 100. I want that to be positive 100. So my other point is 65,535 needs to turn into what? Positive 100. Sometimes people say, oh, well, how do you know what is the first point versus the second point? It doesn't matter. Call the first one, whichever one can be the first one, whichever one can be the second one. But once you do that, then stick with it. And so I'm going to do this as point 1 and this is point 2. You know, you can do it either way. You can do it either way and it will work. All right, so now what do I need? I need to get the slope. So m is equal to y2 minus y1 over x2 minus x1. And what is that? That is minus 100 y2 minus y1, which is 100 over what? x2, which is 250 minus 65, 535. And what is that equal to? That's equal to minus 200 over minus, what's that going to come out to be? That is going to come out to be 65, 285. 65, 285. A minus over a minus makes a plus, and so the slope is going to be the slope is going to be 0.00306. Yeah, 0.00306. It's the same as we got over here, but over here the slope was what? The slope was negative, and over here it's the same number, but it's positive. Now we're going to do the equation of the line. Y minus y1 is equal to m onto x minus x1, and that is going to be y minus y1, which is 100, is equal to positive 0.00306, positive 0.00306, onto x minus x1, which is 65, 535. Now we'll leave the minus 100 for right now, minus y minus 100. We're going to distribute the 0.00306 to get rid of the parentheses, so that's 0.00306x minus 0.00306 times 65, 535, and that is going to be 200. That is going to be 200.766. Okay, you see a lot of this math is very similar. I'll get out of your way before my head covers up the work. It's very similar to the first equation. Now what do I need to do? I need to add 100 to both sides so I can get the y by itself. So I have y is equal to 0.00306x minus, I have minus 200 plus 100, which would be minus 100.766. A lot of times what people say is, oh, well, you move the 100 to the other side. No, you don't move the 100 to the other side. What you do is you add 100 to both sides. There's no such thing as moving. Okay, no such thing as moving. Now let's use the values that we're going to program. And so what is this? This y is going to be, now this is the up and down. So this is the V calibrated is going to be equal to 0.00306x. Okay, not x. I did that last time too, didn't I? What is it? It's V value, the measured value, minus 100.766. Okay, so now I have two equations, and that will allow me to calibrate the left and right with the HCal equation and the up and down with the VCal equation, if I am thinking about this right. So this could be crazy because those are kind of some crazy equations there, but really, who is your friend? Math is your friend. Okay, math is your friend. So let's see if we can get this thing working. All right, let's see if we can get this thing working. I will come up to a little bit better size. I will take a sip of my coffee. And let's just jump back over here to our code view. And this should be fairly straightforward if you wrote the equations down. And so what I'm going to do here is I have HVal, but now what I want is I want to calculate H calibrated. The calibrated value is equal to minus 0.00306 times H val, like that, plus 100.766. All right. I better look at that. Minus 0.00306 times H val plus, that looks good. And then I need to do a V val, and that is going to be equal to, from the equation that we wrote down, 0.00306, it's positive this time, times V value, okay, and then what? Minus 100.766. So those are my two equations. Now what I need to print out, I need to not print out the H val, but the calibrated value, the horizontal, the H calibrated, and the vertical calibrated, like that. Okay, I'm also going to try to make this where it is a little bit more visible on the graph, like this. Okay, now we are going to run this, and hopefully we don't get any errors. VCal, what is this VCal business in line 15? Why did it not like that? This should be VCal. I said it, but I didn't type it. All right, let's hold our breath. Boom. Okay, I'm getting data. And what you can see is really you want an integer value, and it's giving me floating point values. And so what I'm going to do is I'm going to go ahead and change those to integers. And so I'm going to say take this whole thing here and make it take this whole thing here, int, and make that whole hcal an integer. So that'll round it off to the even numbers, and it'll be easier to read. And same thing with this one, the int, make that vcal an integer. And now let's try again. Okay, so what did I want? In the center, I wanted 0, 0, and that is pretty darn close, isn't it? It is pretty darn close to 0, 0. So now what do we want to see? I want to come over here, and if I move to the right, what do I want to see? Positive 100. Boom, positive 100. Plus you can see the blue chart is working. I go back, it goes back to 0, and all the way to the left, giddy up, minus 100. So the horizontal motion works. And also, let's try the vertical motion. So if I go all the way down, minus 100, and if I go all the way up, positive 100. But here is the icing on the cake. Look, if I go horizontally, that's the blue curve very slowly. Okay, I'm moving the horizontal very slowly. And what can I do? I can get all the numbers between 0 and 100 as I move this slowly, or between 0 and minus 100. I can dial in whatever number I want, or the same with the orange. With the vertical, I can go up to 100 nice and smoothly, and then come back to a smooth landing at 0. Okay. Guys, this was a little bit of math, but you see what the importance is now when we work with this. We have very intuitive numbers. In the center, what am I getting? I'm getting 0, 0. And then I go to 100, minus 100, minus 100, 100. And then also if I go like upper right, I'm getting, if I go upper right, if I go upper right, I'm getting 100, 100. If I go lower left, I'm getting minus 100, minus 100. If I go upper left, I'm getting, minus 100, positive 100, or lower right, I am getting 100 and minus 100. So you see, you can really now dial in any number you want. And it's very intuitive. So how cool is that? All right, so that's a big step forward in us using this joystick. But now, you see, like if I was wanting to move something up and down, like control something, I could move it up and down like this and left and right like this. But also, what if I had something, let's just say that you had something, for instance, that you wanted to spin around. Okay, what if you had something in the physical world that you would want to spin around? What do you need to know? You kind of need to know what angle your joystick is at. And so I'm going to go ahead over here, and we're going to think of this in terms of angle. Now, if you think of the coordinate axis in the positive right direction on the x-axis, that is 0 degrees. And then as you spin counterclockwise, that is positive. And so let me just kind of draw that for you real quick here. Let me draw that for you real quick. I'm gonna clear this if I can. There it is. Okay. And so like if I have this axis, and this is the positive x-axis, this is 0 degrees, and then this is the positive direction. Counterclockwise is the positive direction. So this is 0 degrees, 90 degrees. This would be 180, and this would be 270, and then this would come back to 360 degrees. And so you can see 360 degrees and 0 degrees are the same thing. And also what you could see is like here, this would be like 45. This would be 135. This would be, what is that one? I have trouble doing math in my head. That's 225. Because 180 plus 45 is 225, and then this one would be 315. So you see, you can have your joystick sort of at all of those different angles. And so right here, okay, if I'm right here, what do I want to report? I want to report 0 degrees. And then if I go upper right, I want that to be 45 degrees, and then 90 degrees, and 135, and then all the way over here is 180. 225, 270, 235, or 270, 315, and then all the way back over here is 0 or 360. So you see how this is like an angle. You can think of me putting an angle on this. So this is your homework assignment. Instead of reporting the HCal and the VCal, what I want you to report is instead of reporting the HCal and the VCal, what I want you to report what angle. I want you to report what angle the joystick is at. Does that make sense? I hope it does. I see something that I don't like very much, and that is, do you see how I'm not absolutely at 0 in the middle? So I want to clean that little bit of noise out of the middle. And so what I want to know is if I have an X value, I have an X value, and I have a Y value, I want to know how far is that point from the origin. So I want to kind of know that vector that goes to that point that you're moving to. And the size of that vector is the square root of the horizontal value plus the square root of the horizontal value squared plus the vertical value squared. And then that gives you the magnitude. And that would be kind of something useful here. So I'm going to go ahead. What is the magnitude of like how far that point is from the origin? The magnitude of how far that would be equal to the square root, SQRT, square root. Maybe you just learned something new. It might need to be math dot square root like that. And then what do? I take HCal, and then star star means raised to the power of 2 plus VCal star star raised to the power of 2. So that's the square root of horizontal squared plus vertical squared. Okay, now if it's very, very close to the origin, like just 1 or 2, what I want to say is if the magnitude of that thing is less than or equal to 4, meaning it's right there, out of 65,535, it's only 4 off, I'm going to call it as being at the origin, so we don't have that little noise around the origin. So if the magnitude is less than or equal to 4, what am I going to do? Well, I'm just going to say HCal is equal to 0 and VCal is equal to 0. And that way it gets rid of that little noise nonsense right there at the left. So let's see if that works. Okay, yeah, you see 0, 0. And then if I come over here and move it, you see it still works perfectly. But I just got rid of that tiny little noise, you see, and I can go all over and it works very good. Okay, guys, so that is your homework assignment, is to go in and to calculate what angle your joystick is pointing at. And then that's useful for a lot of different things. And so again, we're just kind of learning some math, we're applying some math, we're learning a little coding, we're learning a little engineering, a little embedded programming. And so I hope you guys are enjoying taking these lessons as much as I am making the lessons. I want to take a second and give a shout out to you guys who are helping me out over at Patreon. You guys are the ones that are keeping this content coming. Thank you. Appreciate you standing with me on that. You can also help me by giving me a thumbs up. If you haven't already, subscribe to the channel. Always helps when you leave a comment. But most importantly, as always, share this video with other people, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.